Hello class, this video is about changing repeating decimals into fractions. As you know, repeating decimal are part of a group of decimal we call infinite decimals. Okay, we have two category of infinite decimals, one that has repeating patterns and the other one that does not. Okay, we are not interested in this video in the decimals that do not infinite decimal that do not have a repeating patterns because they cannot be changed into fraction. They are irrationals. So example pi, okay, it does not have a repeating pattern. We cannot change them into fraction since they are irrational numbers. So our focus is on rational numbers, and repeating decimal are part of rational numbers. So how do you change a repeating decimal into a fraction? Okay, here are a few steps that you can follow to help you have. Write down the decimal number. Okay, make note of the number of repeating digits patterns. Set x equal to the number that you wrote down. Multiply both sides of the equation you got in this part right here, part 2, by 10, 100, or 1,000. Okay, one follow by as many as 0 as you have repeating digits. Okay. Subtract the value you got, okay, from the equation of 10 part 3. Okay. You want to take this equation that you got here, subtract this value you got right here. Okay. Get rid of any decimal part left after the subtraction, okay, by multiplying each side by 10 or 100. Usually should not be more than that if you are doing it correctly. Okay. Solve for x by dividing both sides of the equation by the coefficient of x. The number that x is being multiplied by, divide both sides by that to solve for x. Okay. And then simplify as needed. Okay. Now let's go through some examples so that we can see how these steps can be followed. Okay. Now, here is our first example. We want to change 0.3, repeating 3, into decimal. Okay. So note, you have only one repeating digit right here. Okay. So therefore, first step, we are going to write the number we are trying to change. Okay, it's written for us, but for the sake of practice, let's just follow the steps so that, okay, write the number down, 0.3, repeating. Okay, second, set x equal to that number you just wrote down. Okay, I'm going to multiply both sides of this equation that I got by 10. Since I have only one repeating digit, I'm going to multiply both sides by 10. So if you multiply by 10, I will get 10x on this side. Okay. That would equal to 3. Okay, move the decimal point by 1 digit to the right. So 10.33. Here is a place that you have to be careful about. Okay. Now, remember this bar means that 3 is repeated forever. So if I multiply by this side by 10, okay, the decimal point will move 1 to the right, so I will get 1, 3, but the repeating pattern is still continue. So you have to show that uh, uh, write the repeating pattern to show that it's still going on. Okay, it doesn't end when you multiply by 10. Okay, so you have to show that. Now I'm going to subtract this equation here by this equation from this equation right here. So minus x, okay, and on this side I'm subtracting the value of x, which is 0.3 repeating. As you notice, now when you are subtracting 10x minus x, mean 10x, 10 of it, minus 1x, you have 9x left on this side. Okay. Now, 3.3 repeating minus 0.3 repeating. Okay. The repeating 3 minus the repeating 3 give you a 0. Okay. And 3, I have the decimal point. So 3 minus 0 is just 3. 3.0 is just 3. So basically, I can rewrite this as 9x equal 3. To solve for x, I need to divide both sides by 9. And if you simplify this by dividing by 3, you get 3 divided by 3 is 1. 9 divided by 3 is 3. So that gives you 1/3. So x equal 1/3 is the fraction that we obtain. Okay. Because of the fact that this is a long process, I will leave you always column 3, okay, to do on your own. But here we go again. So we have one repeating digit. So write the number 1.2. Okay. Set x equal to the number that you just wrote. Then, since I have one repeating digit, I will multiply both sides of this equation by 10. So right here, I will have 10x. And on the other side, if I multiply by 10, the decimal point would be moved 1 to the right. And I'll make sure that I keep on showing the repeating digit. So that would be 12.2 repeating. Again, the 2 is going on forever. So if you multiply by 10, the decimal point will show 1, 2. The repeating pattern is still going on. So I'm now going to subtract the previous equation, this one, from this one. So subtract x on this side and subtract 1.2 repeating on this side. Make sure your decimal point align all the time, otherwise you may make a mistake. So 10x minus x, or you may say 10x minus 1x, okay, give you 9x, okay, and repeating 2 minus repeating 2 give you 0. the decimal point. So you have 12 minus 1, that's 11. So you still have your equal sign. So you have 9x divided by, you have 9x equal 11. So if you divide both sides, okay, 9x equal 11. We don't need the decimal part since it's 0.0. So divide by 9, divide by 9. And we have our answer, x equal 11 over 9. And that would be, and that's is already simplified. So that's it. That's our final answer. For this time, I know I wanted to leave you the last column to do on your own, but since the repeating digit is, even though it's 1, you have another digit before that. I want to let you know that the process does not change. So still write the number. Okay. Set x equal to the number you just wrote. Multiply both sides by 10, since you have one repeating digit. That would be 54.7 repeating. We move the decimal point 1 to the right. Subtract the previous equation from the second one. So minus x on this side, and on this side I will subtract 5.47. 47 repeating. Okay. Now you may note that right here the repeating part does not align. So that means I have to make some adjustment so that the repeating part can align. Since this is 7 repeating, what I'm going to do is move the repeating part one more digit so that it can align with this repeating part right here. Okay, that's just an adjustment you need to make from time to time. So I will move the repeating. Okay, it's 7 repeating. So that means I can write as many 7 as I want. So I will move it right here. Now what that does is that now I can subtract this 4 from this 7 right here. Okay. So 10x minus x give me 9x. Okay, repeating 7 minus repeating 7, that's 0. And 7 minus 4, that give me 3. Bring down the decimal point. Now you have 4 minus 5, so we cannot, so we borrow 1 from the 5. We get 14 minus 5, so that will give you 9. And 4 minus 0 give you just 4. Okay, so let's rewrite this. 9x would equal to 49.3. Okay, we didn't need this extra 0. So note that you still have a decimal number left. What this means is that you have to multiply both sides by 10 to get rid of this decimal number. So multiplying both sides by 10, I would have 90x equal 493. I cannot divide both sides by 90. Okay, to get my x value. Okay. Now, if you can, it's always a good idea to simplify your final answer. Okay. I'm out of space, and I don't want this video to be too long, and I don't see any immediate number to simplify this by. So now we have two repeating digits right here. So the process would be similar. So write the number 35 repeating. Okay, set x equal to the number we just wrote. Now, since we have two digits that are repeating, we are going to multiply by 100. But you have to adjust after you multiply so that the repeating pattern, you can still see it. So if you multiply both sides by 100, you'll get 100x right here. And on the other side, I will have to move the decimal point 2 to the right. So it would be 35 point. Remember, it's 35, 35, 35. So the repeating pattern is still continuing. Now, what I'm going to do is subtract the previous equation from the second one. So it would be minus x on this side, and on this side, minus 0.35. Make sure your decimal points are well aligned to avoid any mistakes. So the repeating decimal part minus the repeating decimal part will give you 0. Bring down my decimal point, and 35 minus 0 is 35. Still have my equal right here. 100x minus x, 99x. Okay. I don't need this 0.0. So, because I can just go ahead and divide both sides by 99 to solve for x. So that gives me x equal 35 over 99. Okay. So here is another situation. Number 5. We have, first you need to write down the number. Okay. Notice the 1 is not part of the repeating digit. Only 27 is repeated. So you have to take that into account. So we have 2 repeating digits. Set x equal the number that you just wrote. Okay. Since I have 2 repeating digits, I will multiply both sides by 100. On this side, if you multiply by 100, you are going to move the decimal point 1, 2 to the right. Okay. And remember, we'll have to make some adjustments so that the repeating pattern can still show. So let me multiply. So 2 move the decimal point 1, 2 to the right. So that would be 212 point. Now, after that, you see that it's 7 that follows, but we still have to adjust to show the repeating decimal part. So 2 will follow and 7 will follow. So that's the repeating part that we still need to show. Now, subtract this equation from the one that you just got here. So on this side, it's minus x. And on this side, it's minus 2.1 and 27 repeating. Okay. So 100 minus x give you 99x. Now, the repeating decimal, repeating 27 minus repeating 27 give you 0. Now, 7, this 7 right here, minus 1 give you 6. Bring the decimal point down. 2 minus 2 is 0. And 1 and 2. Okay. So, I don't need this extra 0 right here. So, let me rewrite this. 99x equal 210.6. Now, you notice you still have a decimal number that is in the second part of the equation. So to get rid of that decimal number, decimal part I'll multiply by 10. So if you multiply 99 by 10, you get 990x. If you multiply this by 210.6 by 10, move the decimal point 1 to the right. So you have 2106. Now I'm going to divide both sides by 990 because I'm solving for x. So that's give you x 990 divided by 990, that's give you 1. So 1x, just x, equal this right here. Okay. Now, this number can be simplified further. Okay. And After you simplify it, you'll get x equal 117 over 55 for this. Please watch the next video to help you with simplifying fractions. Okay. So I hope you are getting used to it. Again, we are going to write down the number as we have it. Okay. Set x equal to the number we just wrote. Okay. Since we have two repeating digits, we are going to multiply both sides by 100 and make some adjustments so that you can see the repeating pattern continue. So x times 100 is 100x. And 7.89 repeating times 100, we move the decimal point 2 to the right. So it would be 789. But we have to make sure that we keep on showing the repeating pattern. Okay. Now subtract this equation from the second equation you got. So subtracting x on this side, and on the other side, the value of x, I'm subtracting the value of x. Minus 7.89 repeating. So what that will give you is that the repeating 89 minus repeating the 89, that's 0. Make sure you bring down your decimal point. 9 minus 7, that gives you 2. 8 minus 0 is 8. And 7 minus 0 is 7. You still have your equal point. And 100 minus x is 9. The 9x. Okay. I do not need this point 0. But let me rewrite it so that I don't confuse you. So 99x equal 782. Why is it lagging? So I'll divide both sides by 99 to solve for x. So 99 divided by 99 is just 1. So I have x right here. 1x is just x equal 782 over 99. Okay. Okay. Now we have 3 repeating digits. Okay. This means that to make the adjustment, we'll have to be multiplying both sides by 1,000. So first, still same process, write down the number. Okay. Set x equal to the number that we just wrote. Yeah. Now, because I have 3 repeating digits, I'll multiply both sides by 1,000. So 1,000 x. Move the decimal place 3 to the right. So that will be 346.346 repeating. You have to adjust to show that the repeating pattern is still continuing. So subtract the previous equation from the second one. So minus x on this side and minus 0.346 repeating. So right here, I will have 999x. Now, if you subtract 346 repeating from 346 repeating, you get 0. The decimal point. And 346 minus 0 is just 346. I need to make some adjustment so that my writing can fit. Now, 0.0, we don't need 0.0. So we can excuse me, we can rewrite the number. $346. And to solve for x, we'll have to divide both sides by 999. 999. So this will allow us to get x. $346 over I need to move something out of the way to give me some space. Okay. Over 999. Okay. Now this is our answer right here. No, I'm having some issue with my marker. It's lagging. Okay. Since 7 and 9 are similar, okay, I'm going to do this and stop. Number 8 and stop. Marker. Okay. So you write down the number, set x equal 9.1234. Cannot see. So repeating 3 digits, x equal 9.1234. Okay, I'm in luck. Okay, and then we are going to multiply both sides by 1,000. Okay, and while multiplying this by 1,000, I will have to move the decimal point 1, 2, 3 places to the right. So I will have 4 left from the first repeating pattern, and then I need to write more to show the next repeating pattern. 1, 2, 3, 4 repeating. Excuse me, that's a mistake. The 1 is not repeating, so what is repeating is the 2, 3, and 4. So after this 4, 2 comes, okay, 3, and another 4. The 1 is not repeating. That's something to be careful about. So subtract this equation from this one. I have some technical issues, so trying to hurry up to finish this and stop. Okay. Minus x on this side and minus 9.1, 2, 3, 4 repeating. Okay, on this side. So 1,000 minus 1x will give you 9x. Repeating 2, 3, 4 minus repeating 2, 3, 4, that's 0. 4 minus 1, that's 3. And 13 minus 9, that's give you 4. 4. So you have 1, 1, and 9. So the decimal point, let's remember that. Okay. We need not to worry about this 0 right here. So I can get rid of it since I'm in a hurry to finish. So I'm going to multiply both sides by 10 to get rid of this decimal point here. So 9,990 x. would equal to 91143. I'll divide both sides by the coefficient of the x, 9990. So divide this 9990. So you'll have x equal to 91143 over 9990. Okay, I really have to struggle to finish this video. I'll stop right here. But I believe I cover enough for you to be able to understand what this is all about.